welcome. In today's video we are going to be creating a Windows surface that is a binding between our GLFW window, which is up on the screen, and our Vulkan instance and device and everything. Here's another way to think about it. When we started in the first video and we created our GLFW window, we told it not to use a graphics API. And we said, okay, well, we'll be putting one in later. And that's what we're doing now, basically. First of all, I've created a variable to store the surface, which we create. And then the point at which we want to create this surface is after the instance has been created, before the physical device has been picked, because the type of surface that we're working with can have an influence on the type of device, either physical or logical, which is created or picked. Okay, so we'll jump into the create surface function. It's very, very simple. When we created the instance, there was a bunch of extensions that GLFW required in order to function. Let me try to find this. There we are. Get required extensions, which where have I? Here we are. Okay, it's up here. Yeah, so we were calling GLFW extensions, and that returned, this is a list of all the extensions that GLFW needs to run properly. And one of those extensions is we need to be able to create a Windows surface. Okay, so that has been taken into account in the creation of the instance. So, long story short, everything is set up for that nicely, and we just need to call GLFW create Windows surface, and that's it. But of course, the purpose of a window is we want to be able to present things on the screen. In the last video, we were just talking about graphics families, saying that we want a device which can do graphics. But in addition to that, we also want a device now which can present to the screen. And this is kind of what I was saying about like having a Windows surface can affect the logical device or physical device. So in order to do that, we are first of all going to have to modify our Q family indices, because we're not just tracking a graphics family, but we're also tracking the index of the present Q family. So there it is, we've set that up. And then the next point is it's quite simple to modify the completion check. It's just checking whether both of those Qs have been set. And then we need to use that. So we go down to this find Q families. In the previous video, I had this outside as a non-class function, but now I've moved it in. So what we do is, first of all, we create a Q family indices set, and then we loop through it pretty much the same way as before, but in addition to checking the graphics family, we also want to check whether the device has present support. So as we can see, first of all, we assume that it's false, and then we call this function, and that populates present support with the Boolean, indicating whether our physical device can present things or not. And if it can, then great, we grab the index of that Q family. And if it's not, well then, we'll loop around and test again. So as you can see, this seems to be working well. And the reason I had to move this in as a the reason I moved this in as a class function was because I'm now needing a reference to the surface. Now I could set this as a parameter and put it outside, but I see no reason to do it one way or the other, so I just decided to bring it in. Okay. Cool. So now, what do we have here? When we go to create our logical device, we want a logical device which can do graphics and present. However, to be really nitpicky about it, the presentation queue does not have to be the same as the graphics queue. We could have a weird device. We could have, I don't know, an external like workhorse PC doing the graphics computation and then our PC doing the presentation. That's not out of the realm of possibility. So what we need is we need to track the graphics family and the present family, but those could be separate, could possibly be the same. For instance, let's say this is an unsigned integer. So let's say that my graphics card has queue number 5 as both the present family and the graphics family. Well, in that case, we really just want to create one graphics queue because it will handle both. But if my graphics card has graphics as index 5 and then present as index 7, well, then we want two separate queue families to be created. Now, we could do this a number of ways, but the way I chose to do this is with a data structure called a set. Now, just like in maths, a set has unique elements. In C++, if we create a set and then we pass in things which are actually identical, then only one element is added to the set. It's like a vector which only has unique elements. Cool. Okay. Otherwise, the code is pretty similar. So we look through our set of queue families and we create a queue for each of those. Okay, so again, if the indices are separate, then two queues will be created in our logical device. If the indices are the same, then one queue is created. And that's okay because down at the bottom, we want to get the location of the graphics queue and the present queue, which were created when the logical device was created. And if these two are the same, then we'll actually get back a reference to the same thing, and that's perfectly fine. And again, yeah, if they're separate, we'll get two separate references, and that's perfectly fine as well. Otherwise, not much else needs to be done because these queues are created within the logical device, and the logical device will be destroyed at the end. I guess the only other thing we have to track is we need to destroy our Windows surface. Now, the Windows surface is intrinsic to our instance, which means we need to pass in instance as a parameter, and that also means we have to call that before the instance is destroyed. Otherwise, I don't think there seems to be much other dependency there. Cool. So that was just a really quick tour of creating a Windows surface. If we create this, then we get some extension messages, and we have our app working. Cool. Yeah, I think it's funny to read some of these messages. Ray query version 0.0.1. Anyway, it's cool. All right, that'll be it for now. Have fun. Bye.